Hello, fifth graders. Welcome back to a math lesson. Today, we're actually going to review Table C2, and we're going to use Table C1 to help us. And you actually did Table C1 and Table C2 if you were in Mr. Shively or my class last year. But we decided to do a review because these concepts come up often. It also gives us a chance to practice our multiplication. So the thing we need to remember are prime numbers. Remember that prime numbers are numbers that can only be multiplied by one and itself. So in Montessori, we represent prime numbers with a red. And it doesn't, because my colored copy wasn't working, all of these shaded in gray areas would be prime numbers. So 2 would be a prime number. I'm going to shade that red because only 2 and 1 can go in there. 2 times 1 equals 2. There are no other numbers that can go into 2. 3 is also prime because 1 times 3 is equal to 3. 4 is not prime. 1 times 4 equals 4, but so does 2 times 2. And in Table C1, we write the factors, 2 times 2. 5 is prime, so we'll shade that in because only 1 and 5 can go into 5. 6 is not prime. 1 times 6 goes in there, and so does 2 times 3. So in Table C1, we would write 2 times 3. We're not going to redo Table C1. You did this in 4th grade. We're going to, though, review Table C2. I'm going to write, you all have a chart in your math folder, and it's called Table C. I'm going to have you put a little 2 next to it because we have Table 1, C1, Table C2, and Table C3. Table C1 is attached on Canvas, so you can have all of the factors for all of the numbers. But Table C2 is what you're going to fill out. Well, part of it anyway. And let's remember what we do. So Table C2, we are doing prime factor trees. So we are taking factors and, factoring all of them down, and so that the only things left are prime numbers. I'm going to remind you how to do this, and I think you're going to be like, oh yeah, I remember. Let's first actually color in the rest of our prime numbers. We won't do all of them, but at least a couple. Do this with me here so that we're on the same page. Okay, let's look at 12. So 2 factors that equal 12 are 2 and 6. Here's what you're going to do. In your math notebook, you should have a whole page that's going to be full of prime factorization trees. And remember, they look like this. So we have our number, which is 12. And we're going to create a branch like this. Here we're going to write down 2 numbers that multiply to get 12, or 2 factors of 12. Well, we can look at Table C1. We can see that 2 times 6 equals 12, or 3 times 4. Let's do 2 times 6. 2 and 6. We're going to circle prime numbers. 2 is prime because it's colored in red, only 2 in itself. And then we ask ourselves, is 6 prime? Nope. So that means there are 2 numbers we can multiply to get 6. 2 numbers we can multiply to get 6 are 2 and 3. So write 2 and 3. 2 is prime, and 3 is prime. So since everything is circled, we've completed our factorization tree. Now for 12, we can write 2 times 2 times 3. 2 times 2 times 3 is equal to 12. 2 times 2 is 4. 4 times 3 is 12. All right, we got one done. Let's do another together. Let's do Let's do 20, let's do 32. Yeah, 32. So you can either think in your head, okay, what are two numbers that multiply to get 32 besides 1 and 32? If you're not quite sure, you can hop on over to table C1, find 32, and see, oh, 2 and 16 are factors of 32, as are 4 and 8. So I'm going to write, you can choose, I'll do 4 and 8. And then we ask ourselves the question, is 4 prime? If it is, we circle it. If it's not, which it isn't, because 2 times 2 can go into 4. And 2 is prime. Then we move to our 8. Well, we know 8 is not prime. 8, 2 times 4. We know 2 is prime. And then we ask ourselves, is 4 prime? Nope, sure isn't. Factors of 4 are 2 and 2. Now, in 32, now that we have all of them circled, or we've got dead ends, they're all prime numbers. In 32, we would write 2 times 2 times 2 times 2 times 2. Like that. Okay. Let's do one more together, and then I'll let you know what your assignment is. We also have a back here. There's all of our factors for the back. Let's do one of those on the back. Let's do 100. That's kind of a fun one. So we need 2 factors of 100. Again, if you're having trouble of thinking some, go to table C1, look for 100, and here we've got a whole slew of factors. 2 and 50, 4 and 25, 5 and 20, 10 and 10. Ooh, I'm gonna do 10 and 10. All right, now we ask ourselves, is 10 prime? Nope, if we're not sure, we can look at our table C1. 2 and 5 can go into 10, so let's write our factor tree for 10. Is 2 prime? Yes. Is 5 prime? Sure is. That's our dead end. Let's go back to this 10. This is kind of nice because it's the same thing. 2 is prime and 5 is prime. Now we're at dead end, so we can write in our answer. This is where I want you to make sure you write it in correctly. We would write 2 times 5 times 2 times 5, but I want you to put like terms together. So instead of writing on the paper 2 times 5 times 2 times 5, I want you to put the 2's together and the 5's together. So it should look like 2 times 2 times 5 times 5. That equals 100. So we'll put that down here. It's important that you put the like terms together like this because for table C3, you're going to need those. All right, so because this is a review and you did this last year, I'm not going to ask you to do all 100 numbers. This is a review. So what I would like you to do is color in red all of the prime numbers. So we started here, and you can use table C1 to help you. If I would try it on your own first and then use table C1 to help. And just keep on doing all until you get to 100. Kind of like what I'm doing here. Then I would like you to choose 30 of the numbers here to do the prime factorization tree for? 30. Okay, the ones we did in the lesson do not count, so you need to do 30 more. I expect, and you can choose which numbers you want to do, I expect to see a whole page full of prime factorization trees, just like this one here. All right, if you have questions, please ask. Otherwise, you need to, again, color in red all of the prime numbers on both sides through 100, and then choose 30 more to do. So you'll have 33 altogether on your table C2. All right, enjoy.